Hi guys, today we're back for another video. Today we're going to talk about VSEPR theory. Now, VSEPR theory is valence, shell, electron, pair, repulsion theory. Okay, so we don't want to say all that, so that's why we use VSEPR. Basically what it is it says electrons don't like each other. They want to get away from each other. So what we're going to do is we're going to do some more bonding theory. We're going to talk about some stuff that we haven't talked about for a while. Those of you that don't want to do a whole lot of math, don't like to do the math part of chemistry, we're kind of into that section right now. I'm not saying it's easy, but there's not a lot of math right here. So let's talk about what's going on here. All right, so I'm going to start with probably the most simple shape to draw. I don't want to say this it's the simplest shape, but it starts us in the right direction. And I'm going to start with a molecule of methane, which is CH4. Okay. Carbon's going to be our central atom here. I know it's going to be our central atom because hydrogen only needs one electron, so it can only bond one time. I can't stick a whole bunch of things onto hydrogen because it's just not going to happen. So what we have here is we have a central carbon, and carbon has 4 electrons. We have what's called an electron dot structure. So that means I'm just going to draw dots around the carbon. Now I'm going to draw the dots, just the valence dots. So I don't want any other dots, so I'm going to draw it just like this. Because it has 4 in its outermost layer. Okay, and I know that because it is in the 4th family over. Okay, so it has 4 electrons. Now I want to get rid of this too, so I have more room. Okay, hydrogen has 1 dot. Now it wants to share electrons because it's a covalent bond. So when it's sharing electrons, we ultimately want to get to 8 electrons total. Hydrogen can't get to 8 because it doesn't have room for 8, so it only goes to 2, but that's the full row. When we did valence, the electron configurations, that's kind of what we're going at right now, where we want full energy levels. We want those full levels. So hydrogen's full at 2, and I get that by putting them right there. It shares a bond right there. Okay, I have another one up here. It shares a bond. There, it shares a bond. And that gives me my 4 hydrogens, everybody sharing, everybody happy. Okay, this is called the Lewis structure. If I was really drawing a Lewis structure, these would probably be more towards the side. They'd be dots, just like a colon here. Okay, but I like to draw them this way, just so I can simply finish my lines and draw a bond. Okay, mostly what this chapter deals with is how far apart these things are from each other. If you've been in geometry, you should be able to look at this and say, well, they can get as far apart as possible. Right there, all the way around, it's 360 degrees. So from this hydrogen to this hydrogen, that's simple math. That's not 90%. Let's do it this way. Let's do it right. It's 90 degrees. Okay. Now, typically, a lot of times we think of chemistry as being a 2-dimensional subject. We don't view it as being into 3 dimensions where it's actually coming out towards you because the objects are so small. But in reality, they do. So 90 degrees is not going to get us as far apart as we can. In reality, we can actually have stuff that comes towards you, stuff that goes away, and that's why I'm going to change the shape of this particular object. Okay. So here's what it looks like. Here's our carbon. I'm going to leave this hydrogen here. Put a hydrogen down here. And we'll explain what's happening here. Just make sure you kind of get the basics of the shape and what's happening, how I'm doing certain things. Now this is like an art class where something's coming towards you. So I have a small side over here, and it's getting bigger as it's getting towards you. So this is coming at us, so it's coming into our plane, and to go away, you draw a dotted line. Okay, don't say that my artwork just is terrible here. This is actually how you would draw these structures. Okay, so now these have angles. In fact, the angles here are not 90 degrees anymore, but the angle is 109.5 degrees. Okay, that's an important number for you to remember. I told you there's no math, but you do have to remember numbers. So 109.5 is our number there. That gets these electrons here, these particular elements, as far apart as possible. Okay, so 109.5 as far as we can get. Now, this particular structure has a shape. This particular structure is called tetrahedral. Okay, so we have a tetrahedral structure. It is actually called by other orientations as well. And in fact, this one is called SP3. Okay, so this is a hybrid orbital. Earlier we talked about orbitals, we talked about an s orbital, we talked about p orbitals, we talked about d orbitals, we talked about f orbitals. Okay, this is a hybrid. It's not just that particular shape. Now it is a combination of shape. We should talk about this probably a little bit in class, but now is not the time. So sp3 hybrid orbital, you need to know that. Tetrahedral is that shape. Now, let's go into particular shapes that come off of this, because not all of them are going to form tetrahedral shapes. So I'm going to go on to the next one, something that's similar, but is not the same as this. All right. The next one is going to be NH3. All right. So nitrogen has 5 electrons. So I'm going to draw my electrons coming off. And that's it. Now, we know that they want 8 because that's called the octet rule. Right now it only has 5. It's going to get the 8 by adding our hydrogens. So I'm going to add hydrogens where I only have 1. I can't add hydrogens to 2 because that's full. Remember, orbitals can only hold 2 electrons. So I add them where they're not. Remember, I kind of dot sticking out like that so I can just finish my lines when I need them. Okay, a little bit different than the last one. If you'll notice on this one, nitrogen's happy. He's got a little smiley face over here because it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. It's happy, it's full. Okay, it doesn't have anything attached to this. This is where we get the term VSEPR from, valence shell electron pair repulsion theory. So what that says is I have what's called a free electron pair. Okay, free electron pair. These electrons are not bound to any element, meaning that they're going to be a little bit different than what we've seen. Okay, I'm going to go ahead and draw this in 3D so we can see what's going on with it. Now, I always draw my free electron pairs either on the top or the bottom. Makes it a little bit easier for me to draw anyways. Okay, so nitrogen's here. I draw my free electron pairs. Now, how many different attachments does it have off of it? It's got 3 that are bonded to something, and it's got a free electron pair. Okay, so really it's got 4 things coming off of it. So when we talk about orientation, it's still an sp3. Anything that has 4 different things coming off of it, and only 4, is going to be sp3. So our nitrogen is going to be here. It's going to have the same structure. It's going to have the same tetrahedral structure, but just 1 free electron pair. So I'm going to draw 1 coming down with my hydrogen. I'm going to have 1 coming out towards me with my hydrogen, and I'm going to have 1 going off into the sunset. Okay, that's my shape. It's still tetrahedral. Now, we need to get to the actual molecular geometry of the shape, because it's going to be a little bit different. I'm going to tell you why here. Okay, we have a free electron pair up there, right? There's nothing up there. Okay, so our thought is our bond angle is still going to be 109.5 because it's still in the same shape. I am here to tell you not the case. Okay, so if you're just watching this video, just getting really quick notes, don't put this here. It's bad. Okay, what happens is the free electron pair actually pushes down. It hates these guys over here. It's going to squeeze down, and they're going to want to get as far away as possible. Okay, so they push down, and now we have a different bond angle, and that bond angle is 107. Make sure I give you the right bond angles because I've screwed that up many times in the past. That bond angle... Yes, that bond angle is 107. Okay. Now we're in business. So it's just pushed down just a little bit. Make sure you know that it's going to squeeze down a little bit more. Now I have the next element, or the next compound. That next compound is going to be water. Okay, water is H2O. Okay, central element is going to still be, or is going to be oxygen in this case, because remember, hydrogen is always going to be a peripheral element. So oxygen has 1, 2, 3, 4, 5, 6. Hydrogen has 1. And we're in business. Now, what you'll notice on this, it's a little bit different, is I don't have 1 free electron pair, I have 2 free electron pairs. So let's go ahead and draw what that looks like in 3 dimensions. Okay, so our oxygen's here. Now, basically, I'm just going to go ahead and draw the tetrahedral structure, because it is tetrahedral, because it has 4 things coming off of it. Okay, so let's go ahead and put hydrogen to 2 of these. I'm going to put hydrogen here, and just so it's really easy for us to see, I'm going to put it in the same plane up top. Okay. Now, these here are going to be our free electron pairs. So shape-wise, okay, we still have an electron orientation of tetrahedral, but shape-wise, we have a different shape now, and this shape is called bent. Okay, it's called a bent molecule. Bent molecules are going to be very important to us later on because we're going to talk about polarity. We're going to talk about how you have a very strong negative attraction on this side, and you've got a very strong positive attraction over here, or positive charge. I shouldn't say attraction because this is going to charge or attract positive molecules. So this is a polar molecule because we have a very strong negative side and a very strong positive side. Okay, that's what makes water kind of special. I guess I didn't name the last thing. The last one is going to be called a trigonal pyramidal. Okay, because what it made was a 3-sided pyramid. Okay, so go back, put that in your notes. The last one we had, the sp3 with the 109 bond angle or 107 bond angle, is trigonal pyramidal. This one is bent. It has 2 free electron pairs, so what do we think it's going to do to the angle? It's going to go from the 109.5 down to 107, then down to 104.5. Okay, if we get into that area, if we start seeing things that are going lower and lower and lower, we know we have more free electron pairs. Okay, this is as far as I'm going to go on this today. Everything I've covered has been sp3. So sp3 hybridization. We will get to the other hybrids next week. We'll make some of these shapes with the molecules, and hopefully you get a good visualization of what is going on. All right, guys, have a great weekend. Wrestlers, if you're watching this after you wrestle, I hope you had a great weekend. If you haven't wrestled yet, good luck this weekend. See you guys.